Hello everyone, my name is Abhijit from class 5 Utharian, and today I'm going to be explaining to you about color blindness, which is a sex-linked genetic disorder. So what is color blindness? Color blindness is when the person usually cannot see specific colors such as red and green, they mix up their colors, and it usually causes when the recessive allele is on the X chromosome. And it usually occurs in male. That doesn't mean it doesn't occur in female. Okay? So now let's look at this first example here. This is a female which shows, therefore she has the XX chromosomes. Her first X chromosome is the dominant allele, while the second X chromosome is the recessive allele. Therefore, the female is healthy, but she is a carrier, because she got the recessive allele. Okay? Now let's look at the male. The male has the XY chromosomes, and if you see here, his X chromosome has a dominant allele, but his Y chromosome does not have any allele. That is because the Y chromosome is shorter than the X chromosome. If you can see, this is the X, this is the Y. And therefore he is healthy and not a carrier. It's because he does not have the recessive allele on the X chromosome. Remember the definition? Recessive allele on the X chromosome, therefore it causes color blindness. So now let's look at the Punnett square. So we can find out the possibilities of the children, the ratio of what's going to happen to them. The first is the female, so the XX chromosome, which is both dominant, therefore she is healthy and not a carrier. And if you look at the second one, the first is a female also. The first chromosome has the dominant allele, while the second is the recessive allele. Therefore, she is healthy, but she is a carrier of the disorder. And then if you look at this chromosome, the XY, the X chromosome is a dominant allele. Therefore, he is healthy and not a carrier also. If you look lastly, this is the one. X chromosome has a recessive allele and the Y chromosome does not have any. Therefore, is on the disease. He has the disease fit. He has the disorder because there's a recessive allele on the X chromosome. Okay, now let's look at this example. So this example shows that the mom chromosome has a recessive allele and the Y chromosome does not have any. Therefore, is on the disease. He has the disease fit. He has the disorder because there's a recessive allele on the X chromosome. Okay, now let's look at this example. So this example shows that the mom, the female, has two alleles on both her chromosomes, two recessive alleles on both her chromosomes. Therefore, she has the sex-linked disease. Okay, and now let's look at the male. The male has the dominant allele on his X chromosome. Therefore, he is healthy and he has no allele on the Y chromosome, of course. So now let's look at the Punnett square. Okay, this is a different example that we. So for the Punnett square, we can simplify that no girls can get the disease is because both the dominant allele, both on the X chromosome, there's a dominant allele, and but both will carry the disorder. But if you look at the male, the boys, both will get the genetic disorder as they have the recessive allele on their X chromosome. Alright, so now I'm going to show you example 3. So for example 3, we have a colorblind man, but the wife has normal eyesight. Okay, so that means the wife has both X chromosome, she has a dominant allele, while for the male, the father, he will have a recessive allele on his X chromosome, causing him to have color blindness. So if you look at the Punnett square, right, we can see that for the daughter, the first X chromosome will be a dominant one, the second X chromosome will be recessive, same for the one of the daughter. Therefore, she is healthy, but she is a carrier of the disorder. And if you look at the male one, it has both have the X or the X chromosome both has the dominant allele. Therefore, he has normal eyesight. That means he does not carry the disorder, he just has normal eyesight. So that's all from me. Thank you very much.